So the scope of a variable is where it can be accessed and where it cannot be. If you have something like this, you have a function in main, this is not real code, and you declare a variable called x, and then you have another function. Like I said, this is not real code. And you try to get a hold of x, can't do it, because this is local to main. Even if you call the test function like that, right? It doesn't magically make x available to it. If you want x to be available to it, you got a couple of choices. Here's the absolute worst one. I'm going to make that a global variable, and now they're accessible to both functions. That works. It's now a global variable, and it's accessible to both functions, but it's considered really poor programming. You should pass your data in if you want him to be able to access it. There are other ways of doing it once you start doing object-oriented programming with classes. So I could pass that in. Now it's available, right? Because we passed x in, now we can print it out. That's because this is a local parameter variable that gets filled in with the value of x. X gets copied into that one, and we can reuse it. I mean, we can use it down here. Now, the fact that they have the same name doesn't matter. Could have called it I. The value of x, I guess we better assign it something, right? 100 gets copied into here, and he can use that value for whatever purposes he wants to. It is definitely a copy of the data. It is not the original data. If we changed I in here, I++, it does not change the original value. X is still equal to 100, right? But it passed it in there? No, it passed a copy in. Just like I pass in a copy of a dollar bill. If you burn the copy of the dollar bill, I still have my original. Now, unlike some other languages like Python and Java, you can configure C++ so it actually passes the variable in itself rather than just a copy of it, in which case, yeah, if you added one to it, it would change this value as well. But we're not there yet. So let's just accept in faith that a variable that is local to one method, to one function, is not accessible to another one unless it is passed in as a parameter. And that variable stops existing at the end of the curly brace. So if we did this, if we created another variable, string name is equal to Bob, then after we have called test, would we be able to access Bob? Would we be able to access that name? Well, in Python you would, but Python's kind of a weird beast. In this language, this is a local variable. It is local to the test function. And once we hit the close brace, then we've lost all references to it. And so main cannot get a hold of it. How could you get it back to main? You could return it, right? And then we could do something with it. We would have to store the return results in a string here, and then we could get it out, right? So a variable that's local to a function can only be accessed outside of that function if it is returned. So let's write these down as little bitty rules, which we are free to override as we learn more complex programming techniques. So for now, let's say a variable that is local to one function is not available to another function unless it is passed in as an argument to fill a function parameter. Just like this. We passed x in here so that I could use it. It filled the parameter. The longer name for parameter is parameter variable. And I added the word local there because this variable is local only to these braces. It's not, you can't access it inside of another function. If we have another function called test2, not going to be able to get a hold of it. And I can't get a hold of I here. This would definitely be an error. because it's not defined anywhere that it can get hold of. Where is it supposed to find I? It can't see I. I is out of scope. So the scope of a variable is the block in which it is defined, from the point of the definition to the end of the block. So this variable is defined here, and it exists from there to there until the end of the block. That's its scope. Name is defined here, so it exists from there to there. This one doesn't even have any variable definitions. A global variable. I'm going to create a global variable.
Professor,
Yes. Did I start the recorder? No, I did not. That's probably not your question. Oh, I did. What do you know? Yes, ma'am.
so you said that if you want to use X on test on the second one, the second block, you then did string name error test parentheses X to be able to use it on the second block? Or
Yeah, so what I'm doing is I'm passing this variable in so it can be copied in here and be used. And then I have some data here that I want to pass back so I can print it out. So that's what the return statement does, is it sends this data back to be put into there. But I don't know why I put arrow there. That's a completely wrong syntax. That would be far better. And so now it's starting to make sense because I was an idiot and I fixed it. Thank you very much. That makes sense though, right? Since we're returning it, we can store it there. So global variable is available to all these functions. And by the way, of course, if these did not have return types, those would be syntax errors. Starting to look more like real code. Okay, so we could declare like, you know, max memory or something like that as a global variable for whatever purposes. Now this variable scope is from here all the way to the bottom of the file. So it's certainly available here. It's certainly available in there. It's certainly available in there. So a variable that is declared as global can be accessed by any function in the file.
you said that if we declared X as a global variable, that it would be bad coding?
Yeah.
Why?
Global variables are considered fairly bad coding, but they're very useful. And the reason why is, okay, usually I have a good explanation that I can rattle off the top of my head.
But you know you're going to be using X throughout the whole program. Might as well, right?
If you're going to use X throughout the entire program, it ought to have a much better name than X. It ought to have a name like max memory. Yeah. Okay. How about you just accept it on faith that it's considered poor taste, but it's a way that a lot of people do it. In object-oriented programming, you can create global variables, but they're considered part of the class, and that's considered a better way to do it. So one problem is what if that variable has to be used by a... Tell you what, why don't we just Google up why are global variables bad? I don't know why my brain is glitching and I'm not able to give you the reasons that I normally give. Very, very good question. Global variables are bad. Or are global variables bad? Let's find out what they have to say. The problem with global variables is that since every function has access to them, it becomes increasingly hard to figure out which functions read and write those variables. And that's a very good point, right? If I save data to X, well, let's create a global variable named Y. And I set Y equal to a very important value here. Then later on, test might accidentally set that variable equal to something else. And we may not even know it's been changed. It becomes hard to track where changes are being made to it. And so its logic can become kind of convoluted because if multiple, the best thing to do with global variables, and this is a strongly encouraged practice, is to make it a constant. And then it can't be changed. And sure, use it in all the functions that you want. Yes?
Whenever you're passing a variable to another function, you're saying it makes a copy of it. Is that like, does it make like a bit for bit copy, or is it just like a memory pointer address to the original location?
Bit by bit copy. because variable 1 occupies address this one, variable 2 occupies this one, and then when you pass it in, it goes right into it. They're not pointing to the same space. Now, there are exceptions to that in a way, and I don't want to talk about them right now, but if you use pointers or you use references, then they wind up addressing the same space, and so data is not being copied. So, can we accept it?
Yeah.
That is your answer for now? Yeah. Okay. So a variable that is declared as global can be accessed by any function. This is not recommended unless it's a constant, because then one part of the code might be changing it without the other one expecting it. When you call a function and pass a variable in as an argument, the data is copied into the parameter variable. So if you have int test int x and you call test with 100, the bits that make up the number 100 are passed into x. Or if you create a variable and then you call test and pass in a, the bits that comprise that variable, not the memory address of a, but the bits that it holds, are passed into x. C++, unlike Java and Python, do support other ways of passing data in. This is known as pass by value or pass by copy. So Java and Python only support pass by copy, pass by value. C++ supports pointers and references, which change the game here. I'm just going to mention that, and I'm going to delete it. So for now, let's accept that a copy of it gets passed in, but then when we talk about pointers and references, like we will pretty soon, then we can find out that that function actually can get a hold of the original data. So variables with the same name. This is something that this language supports that some languages do not. Specifically Java. What if you have this? Int main, and you declare x, and then inside an if statement, if x is equal to 10, you redeclare x. Well, now x is a string. Is that legal? It looks stupid, but it's legal in this language. If you do this, cout x, and then you do that here, cout x, what is it going to print here? At this one, it's going to print out Bob. What's it going to print out here? It's not going to print out Bob because x no longer exists. X is out of scope. X only exists between that block. So it's going to not print out Bob. It's going to print out 10.
So if it is 10, then it prints Bob.
Yeah, exactly. Right. Yeah, I designed it in such a way that it would go in there and print Bob if that was equal to 10 and otherwise. But anyways, it doesn't matter what kind of block that this is enclosed in. I could even delete that line whatsoever, and it would still print out Bob there, and it would still print out 10 there. That's called hiding, right? There's no way to get a hold of that piece of data anymore now that we're inside here. We can't use this variable for anything because all we can see now is that one. And that's weird enough that languages that followed C++, like Java, don't allow you to do that. And Python, since you don't declare your variables in the first place, you can hardly even manage to try to duplicate that behavior at all. So I'm going to add a comment here that says the original x, which is equal to 10, is hidden because all we can see here is the string x. And by the time we get down here, the string x no longer exists. It's out of scope. So this will print out our original 10, and this would print out Bob. Is there a good reason for that? Good reason to use that? Well, I guess it's kind of good news in as much as I can recklessly create variables inside this thing and not have to worry that they're changing the variables that are declared outside of it. That's about the only reason I can come up why that's a good thing. And that's the end of chapter 4. Once you make a variable global, then any file in your project, any other CPP file can change it. And so that may be totally against the idea of what you think that it's doing. Makes it accessible to the entire project, which is fine if it's a constant and you want everybody to be reading from it. Loops and files. Now, we've talked about loops before. We've talked about loops enough that this is going to be a quick chapter to go through. So we know what plus plus does. It adds one to the variable. Val plus plus is the same as val equals val plus 1. And you can put it in front of the variable or after it. It still increases val by 1. There is a subtle difference, though. If the plus plus follows a variable, it's the very last thing that happens in the statement. Like as in after it hits the semicolon is when it is performed. If it precedes a variable, it's the very first thing that happens in the code before it even starts executing that line of code. So if you have this, int x is equal to 3, and then you have int y is equal to x plus plus, y at the end of this, and this was a test question actually, because we had talked about it, but it wasn't officially in the chapter at that point. So I don't know if I need to take it out and put it in the next one for future generations. So anyways, y is equal to 3 at this point. It's not equal to 4 because this doesn't get increased until everything else is already done. So the 3 gets copied into the y, and then x gets bumped up because it's a postfix, not a prefix. But if you do this, int a is equal to 3, int b is equal to plus plus a, it's the very first thing that happens. And so a gets its value increased to 4, and that gets copied into b. So now they're both equal to 4. Minus minus is the same way, it just means reduce. And in Python, you did minus equals 1 and plus equals 1, maybe, if your teacher taught that. So that syntax also works, but you can just do minus minus and plus plus. Now, why is that there? It's just because adding 1 to a number is such a common operation that they made it easier to program, right? Because you're going to write a loop, and it's supposed to loop in a million times, and x is going to increase each time. You know x needs to increase, so you just put in x plus plus. So you can use these inside expressions, which I don't recommend doing, right? You could say the result is equal to num1 plus minus num2. Now that kind of breaks my brain to look at, but you can do that. That'd be like going into here and saying, you know, int f1 is equal to 3, f2 is equal to 4, f3 is equal to 5, and then saying int result is equal to plus f1 plus f2 plus f3 plus. Now that looks ridiculous. But we could figure out what happens. Everywhere the plus precedes a variable, that means it's the first thing that happens. So f1 would get changed into a 4.
15.
f2 would get changed into a 5. What do you think? Faster than I do if you know that. And then, so 4 plus 5 plus another 5, yep, the result goes into result. 15 goes into result. I'm real impressed. And after all that is done, then f1 equals 4, f2 equals 5, and f3 equals 6. Now, it can be more subtle than that, right? That looks blatantly ridiculous, but it's valid code. But it has to be something that actually is a variable. You can't do num1 plus num2 plus. You better store its result, the result of that into a variable and then add plus to that if that's how you wanted to do it. But you can do it in relational expressions. If you wanted to, you could do if plus f greater than 10. Then do something. That's totally legal.
So if 4 is greater than 10?
It wouldn't be. It wouldn't go in and actually do anything. You know, see out, yay. Right, so well, f1, let's say. Right, so 3 became 4 here, and it becomes 5 here, but 5 is not greater than 10, so it would not print yay. That makes sense? Okay. But we could put it in a while statement. And so when it came in here, f1 is equal to 5, it would print out yay, and it would come back up and evaluate it, and now it equals 6, it would print out yay. It'd come back up here, it's equal to 7, it'd print out yay, so we've got 3 yays in a row. Gets 1 added to it again, it's 8, still way. I should have made that less than 10 if I wanted it to work that way. It wouldn't have done any of this unless I'd made that less than 10. But f1 would go from 5, 6, 7, 8, and 9. So we would see it print 5, 6, 7, 8, and 9 like that. Now if I was going to write this, I would probably take this out and either increment it at the beginning or the end of this, right? To me, that's easier to follow, something like that. But you certainly can put the plus inside the expression. So the while loop, it's a so-called control structure. The other control structures we've seen so far are if, can switch. Flow control is a fancy term for it. Controls where the program is going to go next. And it's used for repeating code. So the general format of it is while expression statement. Now statement could be a whole block of statements if you did that. Now in Python you didn't have to put curly braces around it. In fact, that would be a syntax error. But Python dictates levels of indentation, right? In C, C++, Java use curly braces to denote the beginning and end of blocks. If it's just one line of code, the curly braces are optional. So if I had this here, I'm messing this up a little, but that's okay. Let's start f off at 0 here. f1 is off here. F1 starts at 0 here, what's it going to print? The very first thing it prints. Close. That was if it was 1. 0,
Oh, yeah.
and then it comes down here and it prints out a 1. And then 1 is less than 10, so it would print out a 2 and a 3 and a 4 and a 5 and a 6 and a 7 and an 8 and a 9. And it would not print a 10 because when F1 was equal to 10, then 10 is no longer less than 10. Now, why did I want to say that? That related somehow to this. Oh, okay. Since this is just one line of code, it's legal to do it like that. But if you have 2 lines of code, if you wanted it to do something else, like say y plus or total plus equals F1, you can't do that. Well, you can, but what it's going to do is it's going to complete the entire loop before it finally adds it to the total. The fact that it's indented means nothing to the language. So if you have that, it's treated like this. And if that's not how you want it, if you want it to be left like that, then you better put the braces around it. So that's important enough. I'm going to make it as a comment. While x, y, if y is more than one line of code, it had better be enclosed in curlies. So if the expression is true, just like an if statement, if the expression is evaluated as true, it performs that, but unlike the if statement, when it's done with that block of code, it comes back and checks to see if the expression is still true. And you can get an infinite loop if the thing that the expression is checking never changes, if it's always true. While number is less than or equal to 5, print hello, and then add 1 to number. So depending upon what number began with, it'll print out number over and over and over until finally number is no longer less than or equal to 5. So the expression is evaluated before the loop begins, which makes this a pretest. This is what's known as a pretest loop. Right, we have to be 4 feet tall to enter the roller coaster. That test happens before you get on the roller coaster. It's a pretest. Python does not support a post-test. However, C++ and Java do, meaning a test that occurs at the end of the loop rather than the beginning of the loop, kind of like whether you graduate or not, right? You take some school, and if you don't have enough hours to graduate, then you keep repeating the loop, and finally you earn enough hours to graduate, and it exits the loop. That's a different kind of loop. In general, a while loop is a pretest loop because the test is evaluated before the loop executes. Do I have 2 notepad files going at the same time, and that's confusing me? That seems to be the case. Wait, no, this is all some other lecture. So while loop is pretest because the test is performed before the body of the loop. So while x is less than 10, that means that if x is not less than 10, it won't do the body. There are post-test structure as well, called a do loop. The do loop is a post-test. It looks like this. Do some stuff, do the body, while x is less than 10. So what's the difference? There's no way to stop it from doing the body at least once, right? Because there's no check before that. Doesn't matter whether x is negative million or positive million, it'll still do the body. And then it'll check, oh, you less than 10, and if that's not true, it'll go on, but if it is, it'll repeat it. Whereas up here, this was optional. It does not have to do it one time. It might not happen at all. If x is not less than 10, then that statement would be skipped, but there's no way to skip that statement. That's worth writing as a note. Yes?
Would while be better to use the loop?
Well, it depends on the purpose. The guys who invented Python decided that there was no reason to have a do at all. So it's obviously possible to do programs without a do statement. And when I was writing code professionally, I almost never used the do structure because there's nothing you can do with do that you can't do with while, but it may look a little bit more awkward. At the very least, you could use what's known as a while true loop. This means repeat infinitely. Do my body. And then, oh, by the way, we're going to break out if x is no longer less than 10. Right, so if x is greater than or equal to 10, break. There. Now it's a post-test loop, just like a do loop. It wasn't much harder to set that up than it was to set this up, right? Except the syntax is a little bit more arcane. Because you could have break statements anywhere inside the body. You could have thousands of lines of code and a couple of break statements hidden inside it, and it's hard to track when it's going to leave the loop. Whereas this way, you're pretty sure that you understand when it's going to leave it. So this is implementing a post-test loop without do. How Python users have to do it. I'm not making y'all type code in after me, so some of y'all are going to fall asleep. Wake up! All right. So the loop must contain some code to make the expression become false, otherwise it has no way of stopping, which is called an infinite loop. Now the caveat to that is that if there's a break statement or a return statement inside the while loop, then it doesn't have to ever become false, and that's why we can word this the way we did, while true. But if it never had that, or if x never becomes greater than 10, then it would be an infinite loop. So for example, if I set x equal to 1 here, and we go in this loop and nothing ever changes x, it is an infinite loop, because this is never greater than 10. Similarly, up here, in my good old do loop, x is equal to 1, print out body, while x is less than 10, it's going to print out body forever.
Unless you do like x equal or plus.
Exactly. I would have to update x to get it to not be an infinite loop. So we will say the test expression must become false, or the loop will run, must become false eventually, or the loop will run forever, which is an infinite loop. However, break and return statements can be used to exit an infinite loop. But they make the logic harder to follow.
Oh.
What if you had hundreds of lines of code, and then you had some kind of arcane thing in here? If x is equal to 987, then break. You know, like that. And then you had hundreds of more lines of code. It'd be hard to figure out the logic of it. You wouldn't really know as you were editing the program under what conditions it leaves the loop. So if you are going to use a break, it might be a good idea to only use it one time, right? In the loop, and then you're guaranteed to understand when it's going to leave the loop. And that's why a loop like this, where the way to leave the loop is defined right here, bigger than life, or in the while loop like that, is a better way to do it. But if you need some breaks to get out of it, if that's the way you want to code it, it's certainly a valid programming technique. Set up a while true and then have some kind of break statement inside of it that gets you out of it. That's good for setting up what's known as an indefinite loop. An indefinite loop is one that you don't know how many times it's going to repeat. I'll show you an example of an indefinite loop. So there's two kinds of loops. Definite loops, which are counting loops, effectively. X goes, 1, 2, 3, 4, 5, or something like that. It's going to run a predetermined number of times. The program pretty much knows how many times it's going to run. And then there are indefinite loops. Program doesn't know how many times it will loop. Well, why wouldn't it? Well, what if it opens a file and it's reading, but the file could be 1 line long or it could be 1,000,000 lines long? It doesn't know in advance. What if it's waiting for the user to type stuff and it does not know how many things that the user is going to type in? They may type in 1 piece of data and then want to stop, or they may want to enter 1,000 pieces of data. So that's the kind of thing you do with an indefinite loop. So for that, you can do perfectly well with a while true loop. This is my favorite way of doing it, even though a lot of books do not show it. The current Python scripting class book does show it. I felt gratified because I've never found a textbook before that shows it this way. What you could do is something like this. You could, why don't we actually start doing this in Visual Studio now? So we're on R. Oh, and by the way, no class next Thursday. I will mention this again on Tuesday, and I'll post it and text it and send out email, but no class next Thursday. Let's go ahead and post it as a notice right now. So if you want to start your vacation early, what vacation, right? Anyways, let's go and make a note of that. Thursday the 18th. All right, so I'm going to make a new project. I believe we're on R. Lecture R. Grab my boilerplate. Where's my boilerplate? Oh, yeah. Okay. Confused myself. Thank you. Lecture R.cpp. Paste the boilerplate. All right. So let's do a definite loop first. Like we're going to add up all the numbers between 1 and 10. To add up numbers between 1 and 10, we need an accumulator variable, which will hold the total. Total is a perfectly good name for one. And I'm going to initialize it to 0 so that I can start sticking numbers in it. And then we need a counter. So int counter, int x, something like that. I'm going to start it off at 1. And I want it to repeat up until 100. We're going to add 100 numbers to it. So while counter is less than or equal to 100, total, here's a long way of saying it, total equals total plus counter. Or you could just say total plus equals counter, which is what I'm going to revise that statement to say. And then we may as well print the total out. Total summation of 100 is, in quote, total, arrow, arrow, ENDL. I certainly do not need that hello world statement up at the top. So a definite loop is one in which the program knows how many times it's going to repeat. Now this could be a variable, right? We could have asked the user what we wanted to count up to, you know, make that called limit. But still, the program knows that it's going to be going a certain number of times until it reaches the limit. So that is a definite loop. Definite loops are used for processing series of data, consistent series of data, like a series of numbers or a series of items in an array, in a list. Let's run it, prove that it works. And lo and behold, come on. Oh, guess what I did wrong? It's an infinite loop. I never increased counter. I could increase it right here, but that'd be stupid. I could put a plus plus here. An experienced C programmer would probably, you know, do annoying things like that. I'm going to go ahead and just do it on its own line. All right, and that is true. The summation of 100 is 50-50. Why don't we ask the user what number they wanted to count up to? Nah, let's not. We already have the concept. How about an indefinite loop? An indefinite loop is one we're going to loop an indefinite number of times. We don't know how many times we want to do it. So let's reset total equal to 0, reset our accumulator. And then we're going to do, okay, I'm going to go ahead and show you how the books show how to do this rather than my favorite way, which is using a while true. The books use what is known as a priming read, which is where you get one piece of input, then you have a while loop, and inside that loop you have the next getting of the input. So, cout, arrow, arrow, quote, enter a number to add, colon, space, quote, semicolon. And then let's read that into our variable. Well, we don't have a variable yet. Int data is equal to 0. CIN arrow arrow data. But we didn't tell them that they could enter -1 or -999 or something to quit. Enter a number to add, parentheses, or 0 to quit. That makes 0 our sentinel value. The sentinel value is the value that stops the loop. You don't have a sentinel value when you're using a definite loop. You just know that it's going to go from 1 to 100. I'm going to put that in as a comment. 0 is the sentinel value that tells the loop when to stop. All right, so now, while parentheses data not equal to 0, while it's not equal to our sentinel value, add that to our total and then get it again. Total plus equals data. We could print out our current total, right? Cout current total is space end quote arrow arrow total arrow arrow ENDL. And then we could ask for the next value.
I can't type today. Oh my God.
I'll slow down. I'll put a pause in just a minute. So
no,
now,
you're good. It's
right.
just me. It's just
So cout arrow arrow quote. It's just going to be the same cout we had up there, so I could copy and paste it. Enter a number to add, or 40 to quit. Cool. Except I'm going to make it say enter another number to add, right? And then I need to read that into data, CIN error data. And after that loop, I'd want to print out the total again. Cout error. The final total is space end quote error total error ENDL. Let me run it and then we'll pause, make sure everybody got caught up. All right, enter a number to add. 1, 2, 3, 4, 5, 6, 7, 8, 10, 20, 0. And it stopped. Right? I could have kept going for hours, or maybe 0 was the very first thing I did. In which case it doesn't go into the loop at all. That's considered the textbook correct way to write this kind of loop. What I would have done is a while true, get my data, if data equals 0, break. To me, that logic makes more sense than having to get some input one time and then getting some more input at the bottom of the loop. Alrighty, so we've seen a definite loop and an indefinite loop. So this is a definite loop, and I didn't put a comment on my indefinite loop. Runs a defined number of times. Then down here, I'm going to call this one an indefinite loop. Runs an indefinite loop, runs an indefinite number of times, parentheses, in this case, until the user says to stop by entering a 0. And you know those programs that we could have been writing that said, you know, do you wish to do this again? Yes, no. That would be an infinite loop, right? Calculate this density. Do you wish to do it again? Yes, no. That'd be an infinite loop because we wouldn't know in advance how many times the user wanted to make it calculate densities. And since we talked about do loops, even though we haven't seen a slide about it yet, we may as well do an example of one. Total is equal to 0. Counter is equal to 1. Do, curly brace, total plus equals counter, counter plus plus, and then after my curly brace, while, parentheses, counter is less than or equal to 100. So that's a post-test loop because the test happens at the end. Does it behave differently than the other one? Logically, it gives you the exact same answer. The fact that the while loop is at the end rather than the beginning does not change this at all. However, if we went up here and we changed counter equal to 1,000, then since counter is not less than 100, it would never be added to the total. So our first total would be 0. Right? 0, because it was not able to get into the body because this was not true. However, if we came down here and we set counter equal to 1000, and then we printed out total of do loop equals quote, end quote, arrow, arrow, total, arrow, arrow, ENDL, then it is going to get to add 1000 to our counter because it doesn't check to see if it's less than 100 until after it's already done the body of the loop one time. So, the first time up there with the while loop, when the counter started off 1000, it didn't go into the body, so our total was left at 0. The second time, it did go into the body. So a do loop, the body always executes at least one time. Worth adding as a comment. A do loop, the body always executes, and I should put always in caps, at least once, because the test is at the end. In other words, it's post-test. A while loop, the body executes 0 or more times. It might not execute at all because the test is at the beginning. And that makes it a pretest. Now there's a third kind of loop that we'll talk about, which is a for loop. And a for loop is technically a while loop. It just has a very defined syntax. Make it easier to write a loop. There's nothing you can do with a while loop that you can't do with a for loop and vice versa. I'll state that as a fact because I've never seen one that proven otherwise. So I'll put a comment here. A for loop is a pretest loop because it is essentially just a fancy syntax for a while loop. So what's that mean? What is the syntax for a for loop? Let's write a for loop that does add numbers from 1 to 100. So we're going to reset our total to 0 yet again. And then I'm going to do for parentheses, int space x equals 0, semicolon. Now let's start it off at 1. All of our other counters started off at 1, as I recall. For int x equals 1, semicolon, x is less than or equal to 100, semicolon, x plus plus, curly brace, total plus equals x. That is the exact same thing as our other loop, which I'm going to type again just so that we can compare them. I don't care if you do. Total equals 0, count equals 1, while count is less than or equal to 100, total plus equals count. Like I said, this is an exact copy of the other one. Count plus equals 1. Let me guess, it was called counter because I'm getting underlines everywhere. Yep. Should have just copied and pasted it. All right. And then lastly, okay. These two loops do the exact same thing. Inside the computer, bit for bit, they do the exact same thing. But this is a cleaner syntax for it, right? It only took 4 lines of code to write, as opposed to if I don't count the initialization of the total. Well, maybe I could. It took 5 lines of code, whereas this took 1, 2, 3, 4, 5, 6, 7. And we could narrow this down even further. Because it's only 1 line of code, we don't have to use the semicolon. There. Now 3 lines of code to accomplish what this block does. So
Where are you defining counter exactly?
Counter got defined way up. Way up.
But you said that was the same thing.
Right. So way up here I define counter, and I'm just reusing that variable. If it's messing you up that I use that variable,
No,
then I could, you know.
I'm talking about the for loop.
Oh, where am I defining the counter for the for loop? That is where the counter gets defined, except we called it X rather than counter, because I didn't feel like reusing the variable name counter at that point. I could have. It would do that data hiding thing, where we've created two variables with the same name. Not recommended. But there we go. So I hope this syntax is pretty clear. This is the initialization step. This is that. This is the condition. That is that. And this is the update. So that is that. It's got all three parts. It's just got it all in one little teeny, tiny, concise. This is known as the header or header. I like for loops. I recommend using them anytime you have a definite loop. You can even jigger them around to use to support indefinite loops. But I think it's kind of dumb. But you can. Let me show you what I mean. No, I'm not going to show you what I mean. Anything you can do with a for loop, you can do with a while loop and vice versa. You can leave off parts of the while loop if you want. I could do this. Int x is equal to 1, and then 4. Keep running while x is less than 10, x plus plus, and then do something, whatever the body is. That works.
Well, semicolon?
Yeah, it just means, I'm not going to do any more initialization than you may have already done in the past. That works. We could also do this for, int y is equal to 1 for semicolon, semicolon, y plus plus. And then if we saw y ever no longer being less than 10, if y is greater than or equal to 10, break. That does the same thing as the one up above it, but we've left off two parts of the for syntax. And here's the most ridiculous of all. For, like that.
What?
If z is greater than or equal to 10, then break. But we better update that variable or else it's an infinite loop. So z plus plus. Right. So we better declare z. All right. All three of those are valid for loops. This is the way you're usually going to see it. Like that, right? Where you initialize it, where you have a comparison and you have an update. But you can leave any of those pieces off that you want if you need to or if you think it's appropriate. Now that ought to just be a while true loop. Looks like some crying walrus or something like that. I don't know.
I see it.
Anyways, so the various parts of the for loop header could be left off. You just got to leave the semicolons in place. If you leave off the update had better be inside the code. If you leave off the condition, there better be a break or a return statement in it. If you leave off the initialization, you better have initialized that variable beforehand.
But to do the last one, the Z one, you would have to know the define X and the value for counter to be able to use those two, right?
Right, these are completely separate than the ones with total and counter and stuff like that because this code does not rely on those variables at all. They could be in a separate function. That makes sense? Okay. So an infinite loop. We never changed number, so it's going to print out hello forever. Using the while loop for input validation. We've demonstrated that in this class before. We can loop until the user gives us a good piece of data. So let's ask the user what number they want us to count to. But we're not going to let them enter 0, and we're not going to let them enter a number greater than 100. For some reason, we are real picky about it. So let's set a variable we want to calculate a variable called, I don't know, max. And I'm going to set it to equal to an invalid value first. So while parentheses, I'm going to do this a different way. Sorry. I'm going to declare a Boolean variable called valid, and I'm going to set it equal to false. And then while parentheses valid equals false, which I could rewrite as while not valid. I like that syntax better. It's considered more professional, but the other one is just maybe more clear to you. Pick which one you like. Then let's ask for a value for x. Cout. Enter x between 1 and 100. Parentheses, colon, space, end quote, semicolon. Now we're going to let them type x in. CIN, arrow, arrow, x. And now we're going to check to see if x is a valid value. If parentheses x greater than or equal to 0, 1, and 2 ampersands means and, x less than or equal to 100, then it's a valid piece of data. Valid equals true. That's good data. But if they enter a number that's not greater than 1 or less than 100, we better tell them that it's not valid. So else colon, nope, that looks like Python, sorry. Else cout arrow, arrow, number not in range. Backslash n. End quote, semicolon. That's a data validation loop. And you probably ought to stick that into a function so it could be called over and over and over. So enter x between 1 and 100, 90, 999. Nope, the number's not in range. -1, nope, not in range. 0, nope, not in range. 100, okay, it's good. It accepted that. So it loops until the user enters a valid item, valid data. I'm going to remove the word a there. By correct grammar, I would have to make that a valid datum, and that sounds ridiculous. Nobody uses the word datum, so I'm going to just remove the article a there. And like I said, I would probably put that into a function because I don't want to have to enter how many lines of code is this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every time I just want to ask for a number. Anybody need me to slow down? Come look at syntax errors? Okay. Oh. All right, let me pause it for a moment while you do that. All righty, since it's gone, we'll make up some new ones. Homework. All righty. Write a for loop, no, a while loop that will print the numbers between 1 and 100. Write another while loop, and this is a little bit more complicated because I didn't show you how to do it, but you can figure it out. That will print the numbers between 100 and 1000, skipping 50 each time. So how are you going to do that? Just counter plus equals 50. Hint, counter plus equals 50 might really help you.
Are you overestimating this?
Am I over-explaining?
Overestimating.
No, you can do this, and if you get stuck, take a picture and ask me. Y'all aren't asking me enough questions. I get bored at home. I don't have anything to do. No one's texting me. I'm so lonely. I'm exaggerating, but really, guys, if you get stuck on something, ask me. All right, write a for loop that counts from 1001 to 1020. And when I say count, all it has to do is print the numbers. You know. I'll change that counts to print the numbers. And then if you can, write a loop, a while loop that counts from 20 down to 1. Going negative rather than positive. So you're not going to use counter plus plus, you're going to use counter minus minus or something to that effect. And then lastly, since there's no do loops here, we're going to write a do loop that does the exact same thing as this one. So if we letter these, that's part A, that's part B, that's part C, that's part D, and part E is to rewrite part B using a do loop. All right. That makes sense, gang?
Yeah.
Those of y'all who've taken fundamentals will probably rock right through this. The only thing different is for loops. No, wait, you had for loops and fundamentals. The only thing different is do loops, and they're pretty easy. If you haven't had fundamentals, you'll figure it out anyways. They text me, keep me company. All right, I'm going to switch back to the code for you, but if there's any questions, we can hang out and talk after class. And I need to make a Dropbox.
Yeah.